The discovery of 3I Atlas in July 2025 has ignited fascination and debate within the astronomical community and beyond. This interstellar object, hurtling through our solar system at approximately 60 kilometers per second, represents only the third confirmed interstellar visitor ever observed, following Oumuamua in 2017 and Borisov in 2019. Unlike its predecessors, 3I Atlas exhibits unique and puzzling characteristics that challenge conventional understandings of comets and other celestial bodies. As it approaches its perihelion, the closest point to the Sun, on October 29, 2025, its behavior has sparked intense discussion about its nature, composition, and potential significance. This analysis delves into the most compelling and controversial aspects of 3I Atlas, exploring its rapid brightening, anomalous coma expansion, possible origins, and speculative interpretations, including the provocative idea that it could be an alien artifact. One of the most striking features of 3I Atlas is its extraordinary speed, traveling at 60 km/s, with projections suggesting an increase to 68 km/s at perihelion. It moves far faster than typical comets within our solar system. This velocity, combined with its interstellar origin, suggests it has been journeying through space for potentially billions of years, possibly originating from a distant star system hundreds or thousands of light-years away. Its trajectory is equally remarkable, bringing it within 2 astronomical units, AU, of the Sun by September 2025, and setting it on a course for a close flyby of Mars on October 3, 2025, at just 0.25 AU. This proximity to Mars offers a rare opportunity for detailed observations via orbiters and probes, which could provide critical data on its size, composition, and behavior. Perhaps the most captivating aspect of 3I Atlas is its unexpected brightening. Currently, at an apparent magnitude of around 12, the object has deviated significantly from its predicted light curve, which plots brightness against its distance from the Sun. Observations, particularly from September 7 to 15, 2025, show a sharp increase in brightness as it crossed the 2 AU threshold. This anomaly has puzzled astronomers, as it suggests either intrinsic changes in the object or external factors affecting observations. The brightening appears to originate primarily from the nucleus rather than the surrounding coma, though some uncertainty persists due to limited high-definition imagery. The lack of recent images from major telescopes like Hubble or James Webb, with the latest dating back to August 2025, complicates efforts to pinpoint the cause. As 3I Atlas nears perihelion, its brightness could increase exponentially, potentially making it visible through high-quality telescopes, though it remains below naked-eye visibility. As 3I Atlas approaches the Sun, it has developed a gas coma, a mixture of dust, gas, and plasma that is expanding rapidly, reaching approximately half the size of the Sun, according to Sphere-X observations. Unlike typical comets, which develop tails pointing away from the Sun due to solar wind and sublimation, 3I Atlas exhibits an anomalous anti-tail directed toward the Sun. This sunward coma expansion is highly unusual and challenges existing models of cometary behavior. Additionally, high-quality images from September 17, 2025, captured by astronomers Michael Yeager and Gerald Riemann in Namibia, reveal a strong green hue, likely due to the presence of diatomic carbon, C2. This coloration, not initially expected based on earlier data, suggests new chemical processes may be occurring as the object nears the Sun, possibly triggered by crossing the 2 AU mark. The rapid brightening and anomalous coma expansion are among the most intriguing aspects of 3I Atlas. These phenomena raise questions about whether the brightening results from intrinsic changes, such as increased sublimation of new elements from the nucleus, or external factors like instrumental differences, e.g., camera aperture variations. The sunward anti-tail further distinguishes 3I Atlas from typical comets like C2025 R2, Swan, or C2025 A6, Lemon, which display pronounced tails in the opposite direction. These characteristics make 3i Atlas a unique case study for understanding interstellar objects and their interactions with our solar system. The nature of 3i Atlas remains a subject of heated debate. While some astronomers classify it as a comet due to its coma and sublimation, others question this designation, noting its lack of a traditional cometary tail and its distinct behavior compared to solar system comets. Speculation about its origins ranges from a remnant of an exploded planet to a comet ejected from another star system. More controversially, some propose that 3i Atlas could be an alien craft or technology, a hypothesis fueled by its unusual morphology and the precedent set by Oumuamua, which also sparked similar speculation. These debates are amplified by the object's interstellar origin, which suggests it may carry clues about distant star systems or even extraterrestrial phenomena. One of the primary obstacles in studying 3i Atlas is the scarcity of recent high-definition imagery. The last detailed images, captured in August 2025 by major telescopes like Hubble or James Webb, are now outdated as the object has undergone significant changes in brightness and coma expansion. As 3i Atlas approaches its perihelion on October 29, 2025, capturing clear images becomes increasingly difficult due to its proximity to the Sun. The solar glare, particularly during the superior conjunction on October 21, 2025, when 3i Atlas aligns with the Earth and Sun, will obscure it from Earth-based telescopes. This alignment, occurring in the constellation Virgo near a new moon, exacerbates the challenge, as daylight and light pollution further hinder observations. Amateur astronomers have provided valuable data, but their equipment often lacks the resolution needed to constrain critical parameters like the nucleus size or spectral composition. The rapid brightening of 3i Atlas, observed particularly between September 7 and 15, 2025, has sparked debate about whether the increase in apparent magnitude, from around 16 to 12, reflects intrinsic changes or instrumental artifacts. Variations in telescope apertures, exposure times, and imaging techniques among observers contribute to inconsistencies in the light curve data. For instance, wider apertures may enhance the apparent brightness by capturing more of the expanding coma, which now spans approximately half the size of the Sun. The lack of standardized observations complicates efforts to confirm whether the brightening stems from the nucleus, increased sublimation, or an expanding coma. Forums like Cloudy Nights and Cobb's Comet Observation Database host lively discussions on these technical discrepancies, with some arguing that the light curve deviations are due to observational biases rather than physical changes in 3i Atlas. The upcoming superior conjunction on October 21, 2025, poses a significant hurdle. During this event, 3i Atlas will be positioned directly between the Earth and the Sun, rendering it nearly invisible from Earth due to the Sun's overwhelming glare. This alignment, occurring in Virgo, coincides with a new moon, further reducing visibility as the object will be observable only during daylight hours. The conjunction effectively creates an observational blackout, limiting the window for ground-based telescopes to gather data before 3i Atlas reaches perihelion. This constraint underscores the urgency of collecting as much data as possible in early October, particularly during the Mars flyby, before the conjunction obscures the object. A critical opportunity to study 3i Atlas arises during its close flyby of Mars on October 3, 2025, when it will pass within 0.25 astronomical units of the red planet. This proximity offers a unique chance for Mars-based orbiters and probes, such as NASA's MAVEN or the European Space Agency's Mars Express, to capture detailed measurements. These instruments can target 3i Atlas to assess its brightness, constrain the size of its nucleus, and collect spectral data on its coma composition. The flyby is particularly significant because 3i Atlas's high velocity, approximately 60 km/s, expected to increase to 68 km/s at perihelion, accelerates its sublimation processes, potentially revealing new elements or molecules volatilizing from the nucleus. Data from this event could clarify whether the green hue observed in recent images, likely due to diatomic carbon, C2, indicates a novel chemical process triggered by its approach to the Sun. The Mars flyby provides an opportunity to gather spectral data that could resolve some of the mysteries surrounding 3I Atlas's composition. The object's coma, described as a complex dusty plasma of gas, dust, and ionized particles, exhibits unusual behavior, particularly its sunward anti-tail. Spectral analysis could identify specific molecules or elements contributing to this anomaly, such as C2 or other volatile compounds not previously detected. Earlier observations, such as those from Sphere X, indicated a coma size comparable to half the Sun's diameter, but the lack of recent high-resolution spectra limits our understanding of its chemical evolution. The Mars probe's data could also help distinguish whether the brightening originates from the nucleus or the coma, addressing a key point of contention in the astronomical community. The Mars flyby stands out as a pivotal moment for studying 3I Atlas, offering a rare chance to collect high-quality data before the superior conjunction obscures it. The event's timing, just weeks before perihelion, is ideal for capturing the object at peak activity, as its high velocity drives rapid sublimation and coma expansion. The possibility of detecting new chemical signatures, such as those responsible for the green hue, adds to the excitement, as these could provide clues about 3I Atlas's interstellar origins. Additionally, the flyby's data could refine the light curve, helping to resolve whether the observed brightening is intrinsic or an artifact of observational techniques. The observational challenges have fueled debates about the reliability of current data on 3I Atlas. Some astronomers argue that the apparent magnitude jump in September 2025 reflects instrumental differences, such as varying telescope apertures, rather than a true increase in brightness. Others contend that the brightening is real, driven by increased sublimation or an expanding coma, possibly due to the object's unique composition as an interstellar visitor. The sunward anti-tail remains a point of contention, as it defies the behavior of typical comets, prompting speculation about whether 3I Atlas is a comet, a fragment of a destroyed planet, or even an artificial object. The lack of recent high-definition imagery intensifies these debates, as astronomers rely heavily on amateur observations and limited professional data. The Mars flyby could either clarify these issues or introduce new questions, depending on the quality and nature of the data collected. 3I Atlas, as only the third confirmed interstellar object to enter our solar system, is believed to have originated from a distant star system, potentially hundreds or thousands of light-years away. Its high velocity of approximately 60 km/s, projected to reach 68 km/s at perihelion on October 29, 2025, suggests it has been traveling through interstellar space for possibly billions of years. This extended journey raises intriguing questions about its point of origin. It could have been ejected from a star system during a cataclysmic event, such as a supernova, a planetary collision, or gravitational interactions within a densely populated stellar nursery. Unlike Oumuamua, which showed no cometary activity, or Borisov, which behaved more like a typical comet, 3I Atlas exhibits a unique combination of traits, making its origins a subject of intense speculation. One compelling hypothesis is that 3I Atlas is a fragment of a destroyed planet from another star system. Its anomalous behavior, including its sunward anti-tail and rapid brightening, suggests a composition distinct from typical comets in our solar system. The object's coma, observed to be half the size of the Sun by Sphere X, and its green hue, likely due to diatomic carbon, C2, indicate a complex chemical makeup that could result from planetary material rather than the icy, volatile, rich composition of comets. If 3I Atlas is a planetary remnant, it could carry clues about the geological and chemical processes of its parent system, offering a rare glimpse into the formation and destruction of planets beyond our own. Alternatively, 3I Atlas may be a comet ejected from another star system's equivalent of our Oort cloud. Its rapid sublimation and expanding coma, driven by its proximity to the Sun, align with cometary behavior, though its sunward anti-tail and lack of a pronounced traditional tail set it apart. The presence of C2, not initially abundant in earlier observations, suggests that 3I Atlas may contain a mix of volatile compounds that only activate under intense solar radiation, possibly due to a unique formation environment. This hypothesis posits that 3I Atlas was dislodged by gravitational perturbations, such as a passing star, and has been drifting through interstellar space until encountering our solar system. The coma of 3I Atlas, described as a complex mixture of dust, gas, and plasma, is a key focus of study. Its rapid expansion as the object approaches the Sun, particularly after crossing the 2 astronomical unit threshold in September 2025, indicates intense sublimation of volatile materials. The green hue observed in high-quality images from September 17, 2025, by Michael Yeager and Gerald Riemann, points to the presence of C2, a molecule commonly associated with comets but unexpected in earlier data for 3I Atlas. This suggests that new chemical processes are unfolding, possibly triggered by increased solar heating. The coma's sunward orientation, or anti-tail, is particularly puzzling, as it defies the typical behavior of cometary tails, which are pushed away from the Sun by solar wind and radiation pressure. This anomaly may result from a unique interaction between the object's surface materials and the solar environment, potentially involving ionized particles in a dusty plasma. A central question in understanding 3I Atlas's composition is whether its rapid brightening, reaching an apparent magnitude of 12, originates from the nucleus or the expanding coma. Current data, primarily from amateur astronomers and limited professional observations, suggest the nucleus is the primary source, but uncertainties remain due to the lack of recent high-definition spectra. The brightening could result from increased sublimation of volatile elements, such as water, carbon dioxide, or other compounds not yet identified, as the object nears the Sun. Alternatively, the coma's growth could enhance brightness by scattering more sunlight, particularly if its size exceeds 1 arc-minute, as indicated by some light curve measurements. Spectral data from the upcoming Mars flyby on October 3, 2025, could provide critical insights into the chemical makeup of both the nucleus and coma, potentially resolving this debate. The possible origins of 3I Atlas as a planetary remnant or an ejected comet make it a unique object for studying the diversity of celestial bodies beyond our solar system. Its chemical composition, particularly the unexpected presence of C2 and the sunward anti-tail, challenges existing models of cometary behavior and suggests that interstellar objects may interact with solar environments in unpredictable ways. The rapid changes observed as 3I Atlas approaches perihelion highlight its dynamic nature, offering a rare opportunity to study an object that has likely been unaltered for billions of years until entering our solar system. The nature of 3I Atlas remains a focal point of debate. While its coma and sublimation align with cometary characteristics, its lack of a traditional tail and sunward anti-tail raise questions about its classification. Some astronomers argue it is a comet with unique properties due to its interstellar origin, while others propose it could be a fragment of a destroyed planet, carrying a different chemical signature. The most controversial hypothesis, echoing speculation about Oumuamua, is that 3I Atlas could be an alien artifact or craft. This idea, while speculative, is fueled by its anomalous morphology and the absence of a clear cometary tail, prompting discussions on forums like Cloudy Nights about whether its behavior could indicate artificial design. From a plasma perspective, some researchers suggest that the object's dusty plasma coma, interacting with solar radiation and wind, behaves in ways that resemble complex, almost lifelike systems, raising philosophical questions about its purpose or interaction with the solar system's environment. These debates underscore the enigma of 3I Atlas and the need for further data to clarify its true nature. The discovery of 3I Atlas as the third confirmed interstellar object to enter our solar system marks a significant milestone in astronomy. Unlike Oumuamua, which lacked cometary activity, or Borisov, which resembled a typical comet, 3I Atlas presents a unique blend of characteristics: rapid brightening, a sunward anti-tail, and a complex dusty plasma coma that challenge existing models of celestial bodies. Its high velocity of 60 to 68 kilometers and its dynamic behavior as it approaches perihelion on October 29, 2025, provide a rare opportunity to study an object that has likely remained unchanged for billions of years. Data collected from 3I Atlas, particularly during its close Mars flyby on October 3, 2025, could refine our understanding of interstellar objects' composition, formation, and interaction with solar environments. This knowledge could illuminate the processes that govern star systems beyond our own, offering insights into the diversity of planetary and cometary bodies across the galaxy. The anomalous behavior of 3I Atlas, particularly its sunward coma expansion and green hue, likely due to diatomic carbon, C2, has significant implications for cometary and plasma physics. The object's dusty plasma coma, a mixture of gas, dust, and ionized particles, interacts with solar radiation and wind in ways that defy traditional cometary models. This interaction, described as resembling complex, almost lifelike systems, suggests that interstellar objects may exhibit unique plasma dynamics when exposed to a star's influence. Studying these phenomena could advance our understanding of how solar radiation affects volatile materials and how dusty plasmas form and evolve. The upcoming Mars flyby and potential spectral data could provide critical clues about the chemical processes driving these anomalies, potentially leading to new theories about the behavior of interstellar visitors in stellar environments. 3I Atlas's trajectory, including its close approach to Mars and its eventual path toward Jupiter along the ecliptic plane, offers a unique case study in solar system dynamics. Its high velocity and gravitational interaction with the Sun will test models of orbital mechanics for interstellar objects, particularly how they are influenced by solar gravity and radiation pressure. The object's passage through the inner solar system during a solar maximum in 2024-2025, characterized by heightened solar activity, adds another layer of complexity. Increased solar wind and radiation could enhance 3I Atlas's sublimation and ionization processes, affecting its coma and brightness. These observations could refine our understanding of how solar activity influences comets and other transient objects, providing data relevant to both interstellar visitors and solar system comets like C2025-R2 Swan or C2025-A6 Lemon. One of the most provocative aspects of 3I Atlas is the speculation that it could be an alien artifact or craft. While this hypothesis lacks empirical support, it has gained traction due to the object's unusual characteristics, such as its sunward anti-tail and rapid brightening, which differ from typical comets. The precedent set by Oumuamua, which also sparked similar debates, fuels this speculation. Discussions on forums like Cloudy Nights and in broader media highlight the public's fascination with the possibility that 3I Atlas could be a probe or relic from an extraterrestrial civilization. This idea, while speculative, underscores the human tendency to seek meaning in the unknown and raises questions about how we interpret anomalous celestial phenomena. The lack of definitive data, particularly high-definition imagery, leaves room for such theories, which could be either dispelled or reinforced by observations from the Mars flyby. Beyond the alien craft hypothesis, 3I Atlas prompts deeper philosophical questions about the nature of interstellar objects and their interaction with our solar system. Some researchers propose viewing 3I Atlas from a plasma perspective, suggesting that its dusty plasma coma behaves in ways that resemble organized lifelike systems. This perspective raises speculative ideas about whether such objects could interact with a hypothetical, morphic field, or exhibit a form of consciousness through their complex interactions with the solar environment. While these concepts lie outside mainstream science, They reflect the broader human quest to understand our place in the cosmos and the potential significance of objects like 3I Atlas. The object's billion-year journey through interstellar space, carrying information from a distant star system, invites reflection on the interconnectedness of the universe and the stories embedded in its transient visitors. The fascination with 3I Atlas extends beyond scientific circles, capturing the public's imagination through media, forums, and even merchandise like the 3I Atlas-themed T-shirts mentioned in the original content. Its rapid brightening and mysterious nature make it a compelling subject for amateur astronomers, who have played a significant role in tracking its progress. The object's visibility through high-quality telescopes, though not yet naked-eye observable, has spurred discussions on platforms like COBS and Cloudy Nights, fostering a sense of global collaboration. This public engagement highlights the cultural impact of astronomical discoveries, uniting people in their curiosity about the unknown and encouraging broader participation in citizen science. The scientific significance of 3I Atlas lies in its potential to reshape our understanding of interstellar objects, cometary physics, and solar system dynamics. Its philosophical implications, particularly the speculative idea of alien technology or complex plasma behavior, add a layer of intrigue that transcends traditional astronomy. The object's cultural impact, evidenced by public interest and amateur contributions, underscores its role as a bridge between science and society, inspiring wonder and debate about our place in the universe. The speculative hypothesis that 3I Atlas could be an alien artifact remains the most controversial aspect, dividing opinions between those who view it as a natural object with unique properties and those who entertain the possibility of artificial origins. The lack of conclusive data, combined with its anomalous features like the sunward anti-tail and unexpected C2 presence, keeps this debate alive. Additionally, the philosophical questions about consciousness or purpose, while thought-provoking, are contentious within the scientific community as they venture into speculative territory without empirical grounding. These controversies highlight the challenges of studying an object with limited observational data and the human tendency to project meaning onto the unknown. The significance of 3I Atlas lies not only in its scientific contributions, but also in its ability to inspire wonder and debate, whether it is a comet, a planetary fragment, or something more exotic. Its passage through our solar system offers a fleeting chance to study a relic of the cosmos. The Mars flyby and subsequent observations, if successful, could resolve key questions about its composition and nature, while its philosophical implications will likely persist, fueling speculation about the universe's mysteries. As 3I Atlas approaches perihelion and fades from view, it leaves a legacy of curiosity, collaboration, and the enduring quest to understand the cosmos. Future interstellar visitors will build on the lessons learned from 3I Atlas, reminding us that the universe is full of surprises waiting to be explored.